Alright, so before the break, hey, before the break, we looked at linear equations. We're going to kind of do the opposite today. We're going to look at non-linear equations. It's going to be basically the same thing as before the break, except we're not always going to get straight lines today, which is fine.
Some crooked lines.
Alright, so we're going to look at some non-linear functions, or non-linear equations. So, we got a couple up here. We've got a parabola, looks like a U. This is probably a third right there. And then this is, I believe it's the floor of absolute value. Just a bunch of dots. So, linear we've talked about before. What does linear mean?
Straight line.
Straight line. Non-linear, what do you think that means? Not a straight line. That's all non-linear means. So we are looking at non-linear stuff today. Greg, why is that headphone moving towards your ear?
It's not. It's in my hand.
Greg, put that headphone down. Now.
Suspicious. So, linear, straight line, non-linear is just not a straight line. That's all it is. Opposites. Not super intense or anything, pretty easy. We're going to be looking at non-linear stuff today. And we're going to do basically the same thing. We're going to graph them. We're going to make an equation if we can. The equations today are a little tougher though, which is fine.
It's not fun.
Well, like I'm not expecting you to get them all right away, which is okay. Alright, so we are going to look at this table right here. We're going to graph it and we're going to determine if it's linear. So some of the stuff we're doing today is linear, some of it is non-linear. So let's look at this table first. We're going to graph it. So if I'm looking at this table of Magi, since you're talking, what's this first column right here?
Is the radius column.
Yeah, true, but I mean, is it X or Y?
That would be the X.
That would be X. So remember, when we have a table like this, left is always X, right is always Y. If it's like a long table, like a left and right table like this, then the top is always X and the bottom is always Y. So keep that in mind. So we're going to look at this, and if we're going to graph it, I need to figure out if I need to do anything to change my graphs. So on my X's, what's my smallest X?
2.
What's my biggest X?
10.
So if I'm going to graph these, can I go from 2 to 10 pretty easy?
Yes.
Yeah. So for my X's, I'm going to go by ones. That's not a big deal. But let's look at my Y's. What's my smallest Y?
12.
What's my biggest Y?
12.57.
Yeah, 314, right? Which means that's getting pretty big. Do I want to count up to 314? No, you don't.
I mean, like 5.
Yeah. So let's not do 5s. That's still off. Because that's
6s.
no. How about 20s? No, let's do 50s actually. Let's go 50s. That makes it even easier. So my biggest Y is 314. We don't want to count up 314. So we're going to make our Y's go by some different numbers. So I'm going to make my Y's go by 50s just to make it a little easy. I'm going to make each Y worth 50. So before I graph these, I'm going to go over here and I'm going to say 50 and I'm going to label my Y-axes with numbers. Then 100, 150, 200, 250, 300, 350.
What?
So I could have gone by 25s, but I'm going to make it a little easier and go by this.
50s?
Yep, I'm going by 50s. Because, so, I can go by whatever I want as long as I'm consistent. So I'm going to make each Y be worth 50. So when I graph these, I'm going to have to estimate, which is fine. A lot of our graphs, especially when they have really big numbers like this, we're just kind of estimating. We're not doing like, we're not trying to get them exact. If we were going to do exact, we would use computers. Use Desmos or something. So I'm going to go through and graph these, and I'm going to start with 212.57. So I'm going to go over here, right 2. 12, I'm going to say, is about right there. It's not going to be perfect. It's going to be kind of somewhere between 0 and 50. And I'm going to go towards the bottom of it. And then I'm going to keep going. This next one's kind of nice because it's at 450.27. Over here at 4. Go to basically right at 50. Then I'm at 6, 113. You guys should be graphing these. Remember, you get points for these. We did our notebook checks before the break. Good. So my 6, 113, I'm going to make it go just a little above 100. I have 8, 200, which is kind of nice because 200 is on here. It is right there. Make sure I'm graphing it right. And then I have 10, 314. 10, 314 is about right here. Alright. So, let's connect our dots. But actually, before we do that, let's look at this. Is this linear or non-linear?
Non-linear.
Yeah, it does look a little crooked to me. I'm going to say this, and it is non-linear. This is non-linear, which is fine. We're looking at non-linear equations today. Eventually, we're going to make some equations for them and kind of describe them a little bit. We're just practicing graphing. So, just like before, I'm going to connect these dots, but this kind of looks like a curve, right? Kind of starts off flat, and then starts getting out pretty steep. So I'm going to try to follow the curve even after I connect my dots. So I'm going to start here going kind of nothing, nothing, and I'm going to start getting steeper. And I'm going to kind of keep following the trend of it getting steep like this. So even though we didn't put any dots over here, I can still kind of estimate what my line will be like, which is fine. It's harder to do with these non-linear things because you kind of have to estimate how much it's going to change by. Linear, it's nice because it's going to follow the same amount each time. But this one looks like it's getting pretty steep, so I'm making my line pretty steep. And this is actually about half of what we're doing today. We're just practicing graphing, doing some non-linear stuff, nothing super intense. So anybody still working on this graph? Okay, I'll give you more time. Remember, if I go too fast, just tell me. I want to make sure you have enough time to get everything down. So if I go too fast, let me know. Has it down, Luke?
Stop. What are we gonna do?
She's singing to you.
If you've got this down, please sit patiently while we wait for everybody else.
What? Did I get a what? A what?
Are you leaving, Gabe? Are you leaving? Okay. Make sure to watch the video on Google Classroom later.
You wait. Or a YouTube video.
I gotta get me some more views. A couple hundred more and I might get ads.
Just using the phone now.
No, that would be weird.
Hit a million.
Watch my videos.
Hit a
Click
million
subscribe.
subscribers.
No, that's weird.
You guys, if you guys want to see more videos,
You got it down, Jose?
subscribe.
You got your graph, Jose?
Yeah.
All right.
Buy my merch.
So, it's your guys' turn now. I want you guys to graph these, to graph this next table. As a quick reminder, we've got our X right here, we got our Y right here. So you're going to graph it, and you're going to tell me, is it linear or is it non-linear? So you're going to have to come up with how much is your X going to go by, and how much is your Y going to go by. And I'll give you a hint. My smallest Y is 0.8, my biggest is 4. Should I go by ones?
No.
Yes.
No, probably not. Because if I go by ones, I'm going to fit everything in this little space right here. And that's pretty small.
you
So
need
go by
0.5s.
something smaller than 1. It's up to you.
0.5.
It's up to you. It's up to you.
What?
It's up to you.
We'll go by fours.
That would be even worse. Don't do that. Don't be a rebel, Jace. Just follow the pack. They said 0.5, you go by 0.5.
By 0.25.
You're major. You're that's a good one.
So graph it on your own. I'm going to have somebody graph it on the board for us here in a little bit. Maybe a couple of people.
You gotta make it. Huh? You gotta make it. Oh, man, I messed up.
Luis, graph them in your favor. Hey, hey. Work.
What's up, bro?
So first one was 0.5. First one should be 1. 1.5, 2. 2.5. You went like 0.05. That's what you're going up by. Come on, get to work. Those are nerds. You can help it.
No?
That's right. You're a geek.
So you went by
You're a
0.5.
That's right. I called you that.
1.52.
Whoa.
1.53.
Good.
You accidentally went up by 10.
Delia's right there.
And
So 0.5
And
0.50
Louise, you copy up.
and then 1.
Wait.
1.5.
No.
Keep going. Fine.
So it goes
No, we'll shoot.
0.5.
I didn't know
0.50.
that.
Think of it like 50. You're basically going up by 50s, except put it as small. Like 1.5.
How can you make I?
You should turn the 1 this way.
No.
1.5.
I'm doing it.
3.5.
Shoot.
so
I
bad.
couldn't do
1.5. Up to 4, then you can drop it. Looking pretty good. I'll give you about another minute. Luis, why don't you get started on the board?
honestly, I don't really know if this is linear or not. It's blowing my mind.
Sam, yo, mix it.
But it looks linear, so
Is it linear on Luis?
dude, I didn't.
Alright, Luis.
Hey
What are
guys,
you doing there, man?
it's Luis here, and I'm going to be showing you guys what to do.
I think I forgot what not to do.
Oh snap!
Alright, you go.
That's a good one.
I think I spelled linear wrong.
Come on, Luis. You got this. I believe in you. Come on, keep going. So start by labeling your axes. What are you going by?
Good technical elevator.
Come on. Don't distract them.
Hey, you
Let's
know
go.
what- Hey, you know what I just noticed, Mr. Gold? These all go by A.
We go by
We
8.
could win like 0.8 and like 1.2.
Good job, Magi.
Alright, let's go. Come on. Luis.
Hey, little buddy.
Luis, I'll give you 10 seconds to get started.
Make
No
a
more
wish,
wishes
little
for
buddy.
So help me, I will give you detention.
Hurry. No more practice for you.
Little buddy.
So 0.5.
This one?
Yep. 1.
Alright.
What do you? You're cut off.
Mr. Golf.
This is what happens if you don't pay attention. You look stupid on YouTube.
Are you gonna edit this out, Loki?
No.
Yeah.
Gotta highlight it. Sit. Taking too long. Sit. Alright. So 0.5, 1, 1.5, 2, 2.5, 3, 3.54. Alright. So then, when we graph these, Luis, you should probably copy this down so you get your notebook checkpoints later on. So I'm gonna go 2.8, and I'm gonna kind of estimate 2.8 is about right there. 4, 1.6. That right there. 6, 2.4. 4, about right there. 8, 3.2. And then 10 and 4. Alright, so let's look at these. Does this look pretty linear?
Yes.
Yeah. So it's maybe a little off, but that's mostly because I'm not super good at estimating. So I'm going to make my line here, put my arrows on it. I'm going to call it good. Well, I'm also going to say linear because it's linear. Linear. Alright, that's about half of what we're doing today. We are also going to be making some of our own equations. So, we're going to go to this next part here.
Did you copy it down?
Yeah,
No, I just did it on my own.
need some time to copy those there? Okay. Alright, so we're going to wait a minute, give Elizabeth a chance to finish. Anybody else who didn't get it? Then we'll get started on the next part.
I should run?
Luis, you copied this down yet?
Haha.
Come on, man.
I did.
Where's your line?
And what is it wrong with
Try, man. Just one dots.
Dude!
That's.
Da, da, da.
Just punish the people that were
That's
talking.
what everybody says.
We're a class, we're a
That's because I don't get to be like you guys and piss around. Let's show them
I'm learning.
Bro, I had to help cook too. I had to
I
cook my famous
could.
Joe's
I had to
barbecue.
do dishes.
Yeah, neither should be
We had a lot of them. We have to wait. And we all ate it last
Just do stuff with it. Good shot.
Alright. I'm keeping this.
Please sit tight for a second. We'll let everybody finish this real quick.
Tell the YouTube to wait.
I'll let you.
What?
Hey guys, it's Louis.
Make our own line.
Hey guys, Luis here. Today I'm coming at you with a new video. Please hit the like button and subscribe.
Hit the subscribe button.
And make sure you put the notifications on.
On Christmas?
Still working on this a little bit?
Yes.
Okay.
Mr.
Maybe
Goldkey.
about another 30 seconds.
Mr. Goldkey, can I use the restroom?
Hey guys, like and subscribe.
Got to cut there.
Is the next one hard?
Follow my Instagram.
Hybrid.
Ew. Come on, let it work.
I'll trade you a cookie for a cookie.
Subscribe, like the video. There's more videos coming to you guys. If I get 100,000 likes, I'll do
Yeah, the little one, I did.
a drawing giveaway.
My grandpa has no.
A drawing giveaway. So hit that like button and subscribe. Peace. And then have an outro.
Alright, we're gonna get started again. If you're not done, look on your partner's favor, see what they have.
You like the outro?
Alright, so
And subscribe.
part of what we are doing is we are going to be coming up with our own tables today for some things. So we're going to figure out some of our own patterns. So we're going to look at the table right here. This table shows the total number of blocks in each figure as a function of the number of blocks on one edge. Or in other words, it takes the number of blocks on one side for our x and then our total blocks for our y. So as an example, when I have one block on a side, I have one total block. If I have two blocks on a side, there's 1, 2, 3, 4, 5, 6, 7, 8 total. If I have 3 blocks on one side, there's 27 in this thing total. And then I didn't cover it up on your paper, but we're going to ignore this last column because you guys know how to graph the next one. So I want to know, what is the pattern we can use to complete the table? And then we're going to represent this with, we're actually going to change it and do, let's take out the equation for right now and just do words in a graph. I'll make it a little bit easier. We're not going to do the equation part. So what I need to do first though is figure out this table. And these are a little different. So hey, Luis, come around. So what we're looking at is going to be a little bit tougher today. Because before we just figured out what was the plus or minus. We can't really do that here. So we're going to have to come up with a pattern to finish off the rest of this table. So let's go through and look. I want to know, what can I do to go from my x right here to my y? I want to figure out how I can go from here to here. So I need to figure out that pattern. And I'm going to use the first 3 to find my pattern, and then we're going to go from there. Yeah, Beto? You got it? This cube.
That's nonsense.
Most people don't know that.
I'm not talking about it anymore. I take everything.
So I want to figure out how to go from this left side to the right side. So let's look at a few things.
I take everything.
I want to know, let's look at the plus part first. So make sure you guys are paying attention because this is kind of the hard part today. What could I do to go from 2 to 8?
Plus 6.
I could multiply by 4. I could plus 6, right? Is there anything else I can do to go from 2 to 8?
Minus negative 1.
You can divide by
Or we can do 2 times 2 times 2, right? We'll do Betos 2.
Times 2.
Alright, I want to see if I can find the same pattern here when I go from 3 to 27. So, if I do 3 times 4, do I get 27?
Yes.
No. 3 times 1 is 27.
9.
9.
9, right? Alright, let's put that in there. How about, can I do 3 plus 6 and get 27?
That's scary.
I can do 3 plus 24, right? So that doesn't quite work. But let's keep looking. Let's look at Beto's thing. Beto said, back here on 2, I could go from 2 to 8 by taking 2 times 2 times 2.
Yes,
2 times 2 is 4, times 2 is 8. What about with this 3? What's 3 times 3?
9.
What's 9 times 3?
27.
So, hey, this one works. 3 times 3 times 3 works. Alright, that looks kind of like our pattern. So how about, let's look at, let's actually go up here to 1 and make sure this works. What's 1 times 1 times 1? Alright, so we found our pattern, right? We take this x and we multiply it by itself 3 times, right? So this pattern is going to be 4 times 4 times 4, which is 64. Okay? And then our last one is going to be 5 times 5 times 5, which is 45. Alright. So, we have our table here. We're going to represent this with words. So, when we look at this, we just took the x and we multiplied it by itself 3 times, right? So for my words, I'm just going to say that. I'm going to say took x, and I took x and multiplied it by x 3 times. So for our words, all we need to do is explain whatever pattern we found. It doesn't need to be anything intense. I just need to explain my pattern. So I took x and multiplied it by x 3 times. And now that I'm done with that, I'm going to graph it. To make it a little easier to see, I'm going to erase this part right here just so I can kind of look at my graph a little bit better. It's kind of hard to see. Alright, so I'm going to look at my x's are 1 to 5, that part's easy. My y's, I'm going from 1 to 125. What do you think my y's should go by?
2.
3. By 2s, all the way up to 125?
By 1s.
You want to count by 1s all the way to
25.
125?
Yes.
125.
0.5.
Exactly, go by 25.
25 is a little small. I'll give you guys, when we do these, we want to go
75.
about 10 lines, more or less.
You do it in 9.
So, I want to go up to 125, and I want to do it in about 10 lines, more or less. That makes my graph big enough to see what's going on, but not so huge it's a pain to count.
You got
So let's go by 10s. Let's go by 10s, because that'll do it in about 12 lines. That's not too bad. So I'm going to make my y's go by 10s. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Oh, I gotta go up a little higher. Well, 110, 120, yeah, good enough. Yeah, I missed 3 lines, but it's no biggie. Remember, when we graph these, we're going to be estimating anyway, because I don't know where exactly the number 8 for sure is on here. So I'm just kind of estimating. So I'm going to start graphing. Now that I got this set up, I have 1, 1. All right,
Why
there.
would you go by 10? That takes it forever.
Go by 20 if you want. Do it yourself, Louise. All right, then I have 2, 8. That's about right here. I got 327, which is about right there. I have 464, which is all the way up right there. Then 525, which is way up here. Yeah, right there. Good enough. Alright, this one is obviously non-linear, right? So I'm going to kind of estimate what it's going to look like when I connect my dots. Yeah, good enough. Remember, we're doing these by hand. It's not going to be pretty. It doesn't happen. Not too bad, though. Alright. So, let me think. So, on our next one, we're going to do our table. And we're going to find our pattern, but we're not going to graph our next one. Just to save a little bit of time. But we are going to practice finding our pattern. Actually, you guys are going to practice finding the pattern. So, if you're done, go ahead and look at the next problem. I want you to work on filling out the table, and then I'll give people time who aren't done yet to finish copying this one, and then we'll go from there. So, if you're done with this already, look at your next problem, your next in-class problem. Try to fill out the table on your own. If you're not done with this one, keep working on it, and then move on to it. And graphing takes a long time. So I want to make sure everybody has stuff down before we move on. So I'll keep this on, but if you're done, move on to the next problem. You guys play back there?
Test.
Next test?
Yeah.
Oh, maybe in a couple weeks.
Okay.
Not for a little while.
Hey.
Are you gonna give us time to do
Go
homework?
back to D-Day. I bet you had to do.
What?
I bet you had to play on
Huh?
the group.
What?
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 Huh? Who? Yeah. What? You'll have a little bit of time to do homework. That's why we're not going to graph the next one.
What?
So once you finish with this one, move on to the next problem.
I'm playing on
Move on to the next problem. Get started on it. Try to figure out the pattern.
What?
It's a little tougher.
What?
A little bit tougher on this next one. So try to figure it out. It looks like about everybody's done on that one. So,
No, I'm
Please
not.
do my paper. Someone took
I ain't done.
Bro, I had to.
dang, yeah, copy Moses. All right, so on this next one, we're gonna change it around. We're not gonna do equation or graph. We're just gonna fill out the table. So, look at your table here, which is kind of based on this picture. Figure out what the pattern is.
Jesus
Can
Christ.
I use can I get a drink of water?
In a minute, after this one.
Mr. Goki, I figured it out.
Oh yeah, what was it?
Please take my
Yeah, but she has my
paper.
paper.
Please take my paper.
I figured it out. I used the restroom. God.
Oh yeah.
What?
I'm just trying to get a drink of water.
Bro, go then.
And he said after. And he said in a minute. We lost it. Okay, shit. Lost. Yeah, red.
Mr. Goki?
You're right, Mr. Goki. I didn't figure it out.
This one's a little tougher.
It was really smart.
I think you can help with this one.
What about a tree graph?
Wait till later.
Wait a minute.
So you're figuring out this table is based on this picture here. Are you figuring out the relationship between this side and this side? Or
Are we graphing this one?
so how do you go from 3.7?
Oh yeah.
So let's find the time.
Basketball
Times 2? What's 3 times 3? Times 3? What's 1 times 1?
So 2 to
What is 27 times 30? What is it then?
Alright, I'll give you guys about another minute, see if you can come up with a pattern. I'll give you a hint. The easiest way to look at this pattern is look at your Y's. You can actually come up with a pattern just by looking at your Y's.
That's
Wait, did I do this?
Yeah, I told you it's 71.
Now.
I'll stop there.
Mr. Goki. Right here. Right now.
Yeah.
It's okay when you're with your dad.
Yes, please. You're also going to be moved by yourself.
No.
36, 45.
No, you left it.
The Y's. And my 3 is each time.
Close.
So I think I did this wrong then. Because I went by 3.
Yeah.
Yeah, not quite.
You're not doing that.
Close, not quite. Alright, so let's go through this. Let me see. Lillian, you get the pattern? second. Jace, you get a pattern?
I did it.
What's your pattern?
Oh. Can I go up there and write it down?
Yeah.
Why don't you tell me what it is first?
Let him write it down. Yeah, 'cause I
Let me write it
can't.
out like I'm like some kind of professor. Like I just figured out how to solve.
All right, Jace, go ahead.
Good job,
Right
Jace.
here.
Yeah.
Caleb.
3 3
Sick of you.
equals 9. See what I mean?
Yes.
Right there.
Uh-huh.
Then you get times that by another.
Shut up.
You're gonna get that
Oh,
right
why
there.
don't you say it a little louder?
Right?
Say it a
You're
little
gonna times
louder.
that by 3. And you come over here, you're gonna get 81. You're gonna times that by 3.
It was me.
Hold on, let me see what I got.
All right. So Jace does have the pattern because he's kind of mumbling here.
Then you get 2 4 3.
All right, and because he had a terrible handwriting.
Looks good. I did it
All
right.
right, one more time, just so you guys can see. Hey, hush, we're almost done. Hush.
Did you get from the before?
Ruben, hush. Just wait. Okay, so Jace came up with the pattern here. He said, well, if I start here at 3, I multiply it by 3, I get 9. If I take 9, I multiply it by 3, I get 27. So that means if I take 27, I multiply it by 3, I get my next number, which is 81. Then if I take 81, multiply by 3, I get my last number, which is
243.
243. So my pattern was a little different. I just looked at my Y's on this one. And I got my pattern here. And then we skipped the graphing part just to make it a little quicker.
Leave it there for
What? I
an
did the
extra
graph.
minute or 3.
I told you to skip it. Oh well, you gotta get some good practice in there, man. Alright, so that is it for our lesson. So, if you're done with this, if you're not done, finish this. If you are done, start on your exit ticket. I will turn on Socrative in a second, and then I will put your homework on Google Classroom right after that. So, do your exit ticket, answer it in Socrative, and then get started on your homework.